I'm here representing a fantastic team of faculty here at UCI, and we're all part of the interdisciplinary efforts to enhance salivary bioscience research. Our director is Doug Granger, and we have several core faculty here that we all pretty much live in social ecology and in public health. And Doug Granger, Jenna Reese, and Elizabeth Thomas, I'm going to share some of their ongoing projects today, and all of them are away at conferences and are very disappointed to not be here. We have Kate Kuhlman in our audience, Allison Zalta's coming by, Ilona's coming by, and Michael Hoyt is also in public health with me. So the same excitement that we all have here for neuroscience, and I'm a developmental neuroscientist, I share that with all of you. That's the excitement we have for SPIT over at the Institute for Interdisciplinary Salivary Bioscience Research. So the same aspirations that you guys have and the moonshot ideas that we all have and that we're feeling supported here today to actually maybe act on them, that's what we hope to do for saliva and moving that forward. We have a fantastic team of staff. If you want to contact staff, you can contact any of us faculty members. All of our information's up on the ISBR website. You can contact any of us. We're all happy to help. Caitlin Smith is the manager. She's on maternity leave, so Hillary's filling in, and Tatum are the ones who really do a lot of the business side for ISBR and do all of the assays. They're fantastic. So we're over in Social Ecology 1 here at UCI. We're a huge lab, and we're a shared lab. So I started my faculty position here as a junior faculty member a year and a half ago, and I walked in to having a wet lab that I can call my own that has fancy tools to do really fancy things that I would never even have gotten access to those, even as a senior faculty member. So that's what a community lab allows for all of us. So it really facilitates our careers, but it also facilitates all these collaborations. So if you look and see your research interests, and if they align with any of ours, and you want to kind of dive into salivary biosciences, or you have in the past and you just want more support in doing it, this is a shared lab that we all have. We offer a SPIT camp. It's a 3-day, all-day intensive training, mostly attended by faculty who want to really accelerate their ability to use salivary biosciences. Also, postdoctoral fellows will attend, and you can register up on the website. I have the website address there. I also teach a course for graduate students. It's open to anyone in any department. You register through public health, and it's in the wet lab. We teach it in the wet lab, and even if you don't have wet lab skills, we'll make sure that you are up and running independently by the end of the quarter. That's in the spring. Okay, so I went from animal models, and a lot of things I wanted to look at had to be done in trunk blood, had to look at the actual brain tissue, post-mortem, and I used to think of that really as the gold standard for really understanding what was going on in the brain. And then when I wanted to look at maybe, the peripheral measures of the neuroendocrine functioning, I would then collect blood from my animals, and I could do multiple assessments using the blood collection itself as the stressor to induce it, and then follow up after a certain time period. And all of these are great options. Now that I'm working with kids using multimodal neuroimaging, I've really come to have a better appreciation that the body supports the brain. And these peripheral markers that we're measuring in saliva aren't just kind of really downstream effects indicative of what's happening centrally. They stand alone on their own, because our brain is only as good as the body that can bring oxygen and nutrients to it. So saliva has become kind of the main focus that I've been using to look at biomarkers and connect it to what I see in neuroimaging data. The other reasons that we're really excited and geek out really hard over saliva at ISBR is that it's non-invasive. So people are spitting in tubes, and you don't need a phlebotomist, you don't need any specific specialty training to do this with people, and you can actually have them do it themselves or teach their parent to help them do it. That means you don't have to do it in the lab. My husband's a comedian, so I actually had a grad student during the wet lab course last spring come to our comedy show, and we had volunteers self-sample, and what does watching comedy do to you, right? So we did pre-post, did the comedians and the audience members as a fun learning opportunity, and so you can bring it to all these hard-to-reach populations. There's a physician in the audience that has an elderly or hard-to-reach population. you can look at all these different neuronal markers or indicators of health to people who can't necessarily come into the lab very easily. There's a fantastic poster out there on sleep circadian patterns. We can do all of that. You can send someone home. They don't have to come into a sleep lab. You can have less participants, less animals. You can sample animals. I can talk more about that too, or find me. I'll be here all day. But you can do more with less participants because you have that within subject repeated measures. And so statistically, you just have a lot more power to look at these things. All right. Here's a list, and is not comprehensive. One thing that we really like at ISBR is that all of our faculty members have unique interests, and Elizabeth Thomas, I'll share some of the stuff she's working on, but she works a lot on the development side. So if someone's doing it in brain tissue or blood, she will figure out how to do it in saliva. So here, I look at a lot of the hormones. So I do a lot of hormones. This is all up on the ISBR website too. But people in the ISBR faculty crew will look at therapeutic drugs. So you can have someone self-sample at home and see if the drugs are working. So you can look at all these different markers of disease progression. Drugs of abuse, we can measure cotinine, THC, any drug of abuse you're interested in. And in fact, other studies are doing that. So you can look at differences in metabolism. At a very fine graded timeline within an individual in terms of how they metabolize these. Environmental chemicals, we're all, I'm sure, equally just disturbed by the amount of chemicals and toxins that we absorb every single day. And of course, little kids are so small, so they absorb the same amount, but their bodies are tiny, so they can't, the same amount does a lot more harm in them. So we can take saliva from any age, from newborn all the way up to elderly, and we can assess all these different kind of environmental chemicals, from endocrine disruptors to a whole panel of metals. So Dr. Elizabeth Thomas has really been innovative for adapting blood and analytical machinery to do it in saliva, and the same volume of saliva, you can get a whole panel of metals, like lead. Excuse me, I'm getting over a cold. So of course, other things that might be of interest to people, and I just want to say disease progression, so any markers of disease you can look at, DNA, epigenetics, and then I'm going to talk a little bit more in the other slides about the neuronal markers and uric acid. Another service, if you have saliva or you're an animal researcher and you know that human researcher who has a whole study going on, and if they could just collect saliva for you, it's very cheap, it's easy to implement, but you don't have money to analyze it yet, we can store it for you. We have a huge freezer farm. Okay, so I'm gonna just, I don't have enough time to highlight research from everyone in our group, so I'm just gonna highlight two. One is Elizabeth Thomas, who's away internationally at a conference. She does a lot of work looking at neurodegenerative disease proteins in saliva. But you don't just have to look at someone in neurodevelopmental disease. You can look at neuronal markers that are common to all of us. And you're looking at this in saliva. So why would these neuronal markers be in saliva? Well, if someone has disease, there's obvious blood-brain barrier breakdown, and so things that should stay central go peripheral. That makes sense. But she also sees it after just common concussions. You can see it in the average individual. So this really is such a moonshot idea for us that maybe we could combine for a moonshot idea with you guys, and we can land some undiscovered planet far away. But why is the blood-brain? Sorry, that was so cheesy, you guys. I was like, do I share that? I don't know. Why is the blood-brain barrier opening and closing? Does it do this on a circadian pattern? Does it do it once and then it just stays? Why are these in your periphery? So I work with kids with fetal alcohol spectrum disorder who do have organic brain damage, so I'm exploring these kind of neuronal markers in their saliva. Elizabeth Thomas, looks at individuals with Huntington's disease, brain injury and no injury, and looks at the ranges of these neuronal markers and sees how many she can detect disease states in. So she's really pushing the field. And she also is working with a lot of different samples, disease patients, Division I water polo players, Alzheimer's disease, and military personnel with the Navy. Now, Jenna Reese is working and done a lot to push forward how we understand uric acid. But uric acid is interesting because it's involved in all of these physiological systems that are so important for health. Everything from antioxidant activity, inflammation, to blood pressure. So because it's involved in all of these, it's not surprising that it's related to all of these outcomes, ranging from mental health to very physical outcomes. So she's really looking at it as almost a universal marker of health. And then personally, when I first came to the lab, I had my uric acid measured in saliva. I was immediately postpartum, very stressful time, and I was new faculty trying to set up my lab, and my uric acid was through the roof. And I was just so shocked, and it really helped me prioritize my health. And then 6 months later, took care of an ear infection, all of these things that a new mom doesn't do for herself, and I prioritized it, and 6 months later, my uric acid was way down. So the ability to bring this into physicians' laps to help monitor people at home and then have more individualized kind of tools for medical treatment and individualized treatment is what we're really passionate about at ISBR. We have a table with our fantastic postdocs there. Please go see them and get a stress ball with the saliva, and I'm gonna stop there. All right, thank you so much.